Okay, here's another video about the wheelchairs example. This is in section 3.9, and we're just going to follow along in the book and create an Excel spreadsheet based on this example to help us understand the relationships here between growth and level demand and forecast. So this is example 3.2 in the book, section 3.9. And the section here is talking about forecasting time series with trend. So previous to this section, we were talking about forecasting time series without trend. And in this section, we're talking about with trend. What's a trend? This is increasing or decreasing trend over time. The averaging methods introduced for a stationary time series do not work when there's a trend. In this section, we explain how new averaging methods can be developed to obtain forecasts for time series with trend. Here's an example. A manufacturer has a separate production line used for making specialized wheelchairs for people with disabilities. The firm produces to order after receiving orders from different organizations. This is because each order is different depending on the individual's needs. The demand in the last 12 months has been 57, 254, 335, 307, 342, etc., etc., etc. To plan next month's production, the firm needs to know how many orders it should expect to receive next month. So let's come in here and let's see if we can't create some forecast. I could type this in, but I'm going to try to do some text to columns. Let's see if we can't just make this work here. Not bad. Not bad. Let me come down here and transpose it and take this row out and take this row out. I think we have our demand. So these are months. So why don't I come here and insert a column for month? And these should be 12 months. There we go. We have 12 months. We have demand. So the question is, what's the 13th month? So that's what we're going to try to figure out. We're going to follow the steps in the book here. Step 1, determine the type of time series. Okay, we kind of also know that this is a increasing trend. We can see that here from the data. We're starting out at 57. We're up to 793. Looks like it goes down a little bit here, goes down a little bit here, down a little bit here. But generally, this is an increasing demand. And we can see that if we do a chart. Why don't we go ahead and do a little chart here. Just so that we can all be on the same page. There is our chart. In fact, let me just do this. I'm really interested about that. We have our months. That's our demand right there. Okay, so we know it's increasing. We have a chart like this. We don't have any forecasts yet, but we do have the demand, an actual demand. So let's move on to the second step. Step 2, choose a method. Recall that we modeled stationary time series as demand is equal to L, which is L was the base or level of the series. E was the random noise or error. E for error. The idea behind this model is that demand in each period does not change significantly. It is around L. The main change is due to random noise. To develop a more accurate model, one that includes trend, the stationary demand model can be changed to be the following. we have this level, we have the L, and then G, this is a G, which is some kind of growth rate, which represents kind of an overall growth plus an error. So we're familiar with the level or base and the error. What we're adding here is this G, this growth rate. It could be negative if it is a decreasing trend. In this case, it's going to be positive. What we're going to do is a double exponential smoothing method. So we've talked about the exponential smoothing method before. What we're doing here is a double exponential smoothing method. And this is called Holt's method. So let me see if I can give some basic explanation about the general approach here to this double exponential smoothing method, Holt's method. And then we'll dive in and we'll see how it works. And I think we'll get a better understanding once we start to put all the pieces together. But conceptually, how this works is we are going to have a smoothing constant, not just for the forecast, but we're also going to have a smoothing constant for the trend. So that's why it says it's a double exponential smoothing method. We're smoothing out not just the forecast, but we're also smoothing out the trend. And we see that in some of these math descriptions here. The forecast for the next period is going to include the demand, the level demand, plus the growth rate. And then they're introducing a second smoothing constant, which is this beta. And the beta is going to allow us to smooth out the growth rate. So if we look at the entire new formula, we have an alpha and a beta that helps us smooth out not just the forecast. The alpha is the smoothing forecast constant, but we have a beta that helps us smooth out the growth constant, this growth factor. The trend is the growth. And in order to do that, what we're going to do is let's go ahead and set an alpha here. And we'll follow the book along. We'll follow pretty closely to the book if we can. So we'll do an alpha of 0.5 and a beta of 0.3. If I can give myself a little space here. Alpha equals 0.5 and a beta equal to 0.3. And the way this works is we're going to set our first base level demand equal to the actual demand from period 1. So what this would be like is we're going to say our base level demand, we're going to call that level 0, is equal to our demand for that first period. Now let's see if I can come in here and make this a little bit fancy and do a subscript for that 0. Again, to follow along with the book, in addition to our base demand for level 0, we also need some kind of growth rate. Where do we start with our initial growth rate? And this formula here gives us what that initial growth rate is. We're going to take the demand of the last month, which is 793, subtract that, 793 minus 57. 57 comes from the first month's demand. So we're taking the difference between 793 and 57 divided by month 12 and month 1. So this is saying in 11 months, the demand has grown per month by 66.91. Does that make sense? That's our baseline per month growth. Now that we have our base level demand, which is 57, and I can calculate our base growth here, and that's equal to, we'll take the 793 minus the 57 divided by the 12 minus the 1, and that gives us 66.91. Let me also do a subscript for this one. Okay, so we have our base level at time 0. We have our growth level at time 0. Now we can forecast for month T1. That forecast is going to be adding the 57 plus the 66.91. What we're going to do, though, is we're going to add those two together for every month. And I started up here with the zeros just to give us a pre-month 1 number. But we're going to have to do this for every month. So I'm going to create a field here for our base level demand. I'm going to create a column here for our base, excuse me, our trend, our growth trend. And adding those together is going to result in our forecast. Scoochie this over a little bit, our chart. And let me do a little formatting here. I'll center these and let me just bold them. Let me do a little subscript here. Seems to make that presentation just a little bit cleaner, a little bit easier to understand. Subscript these. Okay. So what we're saying here, now we have to be a little bit careful about what we're saying. What we're saying is the previous period's base demand, which is 57. So I'm looking at now the forecast for month 1. The way to calculate the forecast for month 1 is to go to the base demand of the previous period, which is 57, which is that assumption. The book makes this assumption here, plus a base growth rate, a starting point for that growth rate. Where do we start that growth rate? We'll add those together, and that becomes the forecast for the first month. Isn't that interesting? I think it's kind of interesting. And so what I can do here is I can reference the forecast for the first month is going to be that number right there. So there we have this from the book. The forecast for that first month is 123.91. So here we have, and most of this first month's forecast is based on some of these assumptions about how to get started, right? And that's what these calculations are. In order to get started, we have to make some assumptions. Moving forward to the second month is where we see both the alpha and the beta. They come into play, and that's the double exponential smoothing. We're smoothing our base level demand, L1, with our alpha, and we're also using a beta number to help us smooth out our growth rate, have a consistent growth rate. But we have the same structure here for identifying the forecast for month 2, which is the forecast for month 2 is that base demand of the previous month plus the growth rate. And so let's work through this calculation and let's put this into our table, and we can begin to see how this is going to work for all the months. Okay. So what is the base L, base level demand for month 1? Notice we only have the forecast for month 1, but we don't yet have the base level of month 1. We have the base for month 0, right, previously. What we're trying to do is we're trying to move forward down this table for forecasts, and each of these forecasts will pull from the previous period's base level demand and the growth. And here's the formulas for these. So for the base level demand of month 1, we'll do equals. We're going to go grab the alpha. I will anchor that. We're going to multiply that by the actual demand, this is 57, D1, 57, plus 1 minus the alpha, I'll anchor that, times, now at this point we do the base level demand plus the growth rate, which is what? That's actually the forecast of month 1. See how that's 57 plus 66.91. In order to follow along with the book, I will use those numbers explicitly. So we're doing the 57 plus the 66.91. That entire equation is going to give us 90.45. There it is. So far, so good, right? That is the base demand that we would expect. It's the base level demand, LT, for month 1 based on the alpha and the beta, or excuse me, just the alpha at this point, and the forecast. Pulling from these numbers up here. Let's move forward to the G1, which is our growth. And this is where the beta comes into play. So for this calculation, we'll pull from the beta. I'll reference that. Or I'll anchor that reference. And I'll multiply that by L1 minus L0. Close parentheses, plus 1 minus the beta, which is 0.3. I'll anchor that. Times the previous period's growth, which is 66.91. We should see 56.87, and there it is, 56.87. Now we can use these two numbers to calculate our forecast for period 2, which is, forecast for period 2 is going to be this 46 plus the 56.87, and that's going to be 147.33. 147.33. Okay, so far so good. So again, we're using a double exponential smoothing method. We have an alpha, we're smoothing out our base level demand with the alpha. We have a beta, and we're smoothing out our growth rate, or our per, it's actually not the growth rate, it's actually our per month growth, right? Using the beta. Okay, so if we are, if we have these formulas in a row, if we have our ducks in a row, there's one minor change we need to make when we do these numbers. We're pulling from these up here. So if I were to do this formula for L2 and G2 one more time, then we can copy all these formulas down and find out what our forecast is going to be for essentially week 13, which is where we're going right here. So for the purposes of this table, let's do this L2 and make sure we have our L2 that agrees with the graph here, with this graph in the book, and then we can copy these three down, and then we'll do some errors as well. We'll do some error calculations coming up. Okay, so L2 is equal to our alpha, I'll anchor that, times previous demand, excuse me, our current demand, right? Because we're doing L2, so that needs to line up with D2. So I'll multiply it by our D2, actual demand, plus 1 minus the alpha, I'll anchor that, times previous periods L plus previous periods G. And that should give us 266. Okay, so we're lined up here with the book. That looks good. Let's do our G2. So for our G2, if this is G2, we're looking for L2 minus L1 here, and G1 here, as well as our beta. So that equation is going to be our beta, I'll anchor that, times our L2, because we're on G2. So we're finding G2, so this is going to be our L2 minus our L1, the difference between those base demand levels, plus 1 minus the beta, I'll anchor that, times our G1. Again, we're looking for G2. This is going to be G1, and G1 is right there. Once I do that, we should have 72.87, which agrees right here. So this looks good. Now I believe what we can do is we can copy these down, and we can see if these match. So if we look at the forecast for week 12, and the book is 699.33, we have 699.33. That is a good sign. So what we've done now is we've created a forecast, and we can come back and we can add that forecast to our chart, and we can get a very close chart to what is in the book. And let's look at that. So here's their chart in the book. Here is our chart in our spreadsheet, and that looks really close. If I shrink it down a little bit, it might even look a little bit closer. So we have our demand in the blue and our forecast in the orange. And here we have our demand is the high one here, forecast is the low one here. So we're doing pretty good so far. Now, the next step is to evaluate the method. And the objective here is, hey, let's optimize our alpha and our beta. And the way we do that is with our MSE, mean sum of error, square root of error. So let's do a couple of error columns here. First one will be our error of each period. Next one is going to be our error squared. And let me see if I can do a superscript here and a subscript here and a subscript here. And let's do some error. So what is the error here? Error is going to be forecast minus the demand. That's how we're going to measure our error. Copy that one down. What's our error squared? We're simply squaring our error. Let's try that again. Square the error. Oh man. What's up with the digits? I'm not sure about that one. Let's see. Let's do 2 digits here. In fact, let's go ahead and center all of this on the table. And let's check. So we have 44, 76, 83. Okay, that's right on. We have 87, 73, 41 for month 12. Let's do some totals. I'm just going to sum these up. $46.17. 49.17. If I wanted to match the book, I probably could go a little farther out. That's pretty close. Let's see. No, I'm not squaring this. Excel thought that was going to be a square. I'm going to go ahead and sum this is what I want. 54,988.80. Very good. From a mean perspective, what is our mean? We're going to take the average. The average is 4.10. Or if we want to do some more decimals, carry that out to the book, we could also do that. And then what is the average of a mean squared error? 45, 80, 20, 82, down 40. Let me see if I can center that. Okay, great. So what we've done is we've calculated our mean squared error, which is 48. That's 4582.40. Now we're going to use some solver to say, hey, choose alpha and beta so that we minimize our mean squared error. And we have to put the constraints in there. We have to identify what to change, what cells we're going to change, and make sure that we're using the nonlinear solving method. So let's do that. So I'll go to my data tab. Let's see, I just noticed my file is not saved. Let me go ahead and save this. And I'll save this as chapter 3. Wheelchairs example. Okay, so if I go to the data tab, click on solver, it already selected H2 because that's where my cursor was on, H22. That is my mean square error. What I want to do is I want to minimize that. So the objective here is to minimize my mean squared error. That's how solver knows when it's done, is when it keeps calculating and any other calculation it does, it can't get any smaller. That's when it knows to quit. We're going to change my alpha and the beta. We're going to select both of those cells at once. So I'm selecting both of those cells as my changing variable cells. But I need to add constraints to that to say, okay, look, my alpha has to be less than or equal to 1. My alpha has to be greater than or equal to 1. 0. Right? It's got to be between 0 and 1. And the same thing for my beta. My beta has got to be less than or equal to 1. And my beta has got to be greater than or equal to 0. I'll click OK on that final constraint, and I've added all 4 constraints there. These are following the book, referencing the correct cells here for my alpha and beta. Just trying to make sure they're between, including 0 and 1. And then the last step here is to check on your solving method. We're doing the nonlinear method, and this looks good. So I can click on solve. It's going to do some crazy calculations, and you should see a window that looks like this. Solver found a solution. The option is to keep solver solution in the spreadsheet. I'll click OK, and that will give me the alpha and beta that optimize or that minimize the mean squared error, which is pretty cool. Okay, so the fifth step here, and I believe this is the last step, yeah, the fifth step is now that we have optimized an alpha and beta, given the previous 12 months of actual demand and forecast, and 2 smoothing constants, we can now develop the forecast. How do we do that? The same thing we've been doing, right? The forecast for week 13 is level demand of 12, which is 761, plus that growth amount, 63.96. And that's going to be our forecast for week 13. So let's do this. Let me come down here. We'll do a 13, a week 13. And we don't know what the demand is yet, but we're trying to calculate the forecast. The forecast is going to be the previous period's level demand plus the growth. And that's going to be 825. Mine says .65. I think that's a little bit of rounding. My alpha and beta are much more digits than I think what they're using to calculate this 825.64. So there's a little bit of rounding off the 100th decimal. But still pretty close. This last part here is saying, okay, let's do a prediction interval. And we've seen this a little bit before, so I won't spend too much time on this. We have our standard error calculations. Once we know what our standard error is, we can create a forecast interval. Right now we have a point forecast, but we can create an interval. And the way we do that is we use this formula. In fact, let me go ahead and copy this from the book into here, just to give us a good grounding here, good sense of what we're doing. And then I like to go in here and provide the border. Here's my border. And let's do this calculation. So what we need is we need the bias, we need the SSE. So let's calculate those. The bias is going to be, if we remember, it's going to be the average error. So there's our bias. And then the SSE, we've already calculated. That's going to be our total squared error, not mean, our total squared error there. And now we can take this and we can put it into our standard error calculations. So let's do that. Here is our standard error. And let me move this up here. And we're going to create this calculation right in here. So it's going to be the squirt. I'm going to do a double open parentheses. I'm going to take my SSE minus my T. What is T? That's my number of months. T is time. Times my bias. And that's going to be squared. I'm going to close my parentheses, divided by, open parentheses, my month again, T minus 2. Okay. That is the standard error equation. So when I do my standard error, it comes out to 66.41. Look at that. It worked. We got it. It's a great sign. Next, we need to do our probability. And this is going to be done with our z-score. What we're trying to do here is we want a 0.95 z-score. The way we do that is we're going to use the norm SINV, which I think they redid this one. Yeah, the newer version, same calculation. Norm.s.inv. And the probability here, we talked about this in class, we're going to do 1 minus 0.95 divided by 2. We're taking the difference of the 0.95. We want the outside of the 0.95. And then we only want the top portion of that instead of the lower portion with the higher portion. So we're going for a very upper end portion of that. It's negative 1.96. That's the number that we're going to use as part of our z-score to calculate our prediction interval. So we needed that. So we have our 6641, we have our negative 1.96, and we also have our forecast, which is 825.65, 64 in the book. Now we're ready to calculate these intervals. So we can do a high interval and a low interval. And the high is going to be, we'll take our forecast. We're just following along here with these calculations. We're going to do plus and minus. The high is actually going to be the minus. 66.41 times negative 1.96. That's going to give us our high. 955.82. The book says 955.80. Again, this is just rounding. We have some precise numbers here in our alpha and beta. We have some more decimals. On the low end, it's going to be, again, our point estimate plus our error times our 95% probability, and that gets us our 695.48, which is very close to the book. Actually, it's exactly the book. So those are the answers for week 13. The forecast is 825. That's 65 with a high and a low based on a 95% probability. And then the last step here is the book says, hey, we can also do week 14. Let's do it. So we can forecast out week 14. There's one small addition that we do to this. And first of all, what we're going to do is we're going to find the forecast for week 14 by doubling the growth for week 12. Okay, so let's go ahead and do, I don't know if this is messy or not, but we'll try to do a week 14 right here. What's the forecast going to be? The forecast is going to be the level demand from week 12. Look at that. Plus 2 times the growth from week 12. And that's what we're doing here. We have a level demand week 12, 761, plus 2 times that growth from week 12. That's going to give us our forecast for week 14. Now that we have our forecast, we can come down here and create our interval using a 95% prediction interval. And there's one small addition we need to make, which is because we're forecasting 2 periods out, there's one more calculation we need to make, which we can do right here. And we include that in our formula. And that gives us a little bit wider bands is what's happening here on our interval forecast. So in order to do that, let's look at our, this is what the book calls D2. Actually, we'll put that right here. We'll do a subscript on the 2 just to follow along with the book so it's a little bit more clear. And let's see. We're going to look over here to the book and do that calculation. So the D2 is the 0.397. Okay, so where is the 0.397? Who knows what that's about? What we're doing here is we are taking this formula here. We're just taking alpha squared times 1 plus beta, that squared, is equal to this number. And we get this D2, we plug that into this formula here, and that gets us our intervals. So what we need to do for this D2 is we'll take our alpha, and we'll square it. Here's that 0.397. We're going to square that puppy, and we'll do 1 plus beta, close parentheses, squared on that. So this is the formula. I'm just using this formula right here from the book. Alpha squared times 1 plus beta, parentheses squared. That should give us 0.168. Hey, there we go. 1682. Now we can take that 0.168, plug that into this 95% prediction interval forecast formula to come up with our low and high intervals to help us be 95% confident that the true demand is going to be inside these intervals. So let's do that. Let's see. Let's figure out what our we have our 66.41. We have our 95%. There's the z-score, and then we have this on the end as the different one. So let's do this. This is going to be the same standard error. I can copy that down. $66.41 is going to be our standard error. Let's do this here. We need our standard error. And the standard error calculation is going to be 66.41. And that's going to be the same. That's not going to change. What is going to change is we're going to add a little bit of a factor here because we're forecasting 2 periods out. But the standard error is still going to be the same. So if I come up here and just copy this formula straight out of there, I guess I could just reference it. Even better. Let's go ahead and calculate the z-score. So this is also going to be the same. We're not changing the z-score, but we'll include it here. 0.95. And again, we're going to use the norm.s.inv. Probability is 1 minus that 0.95. That's going to give us 0.05 divided by 2. We're going to cut that in half. It's going to give us the negative 1.96. And again, we have some more decimals there, which is going to affect some of the rounding. And now we're ready to plug in our interval forecast formula here. So we're going to look at our high and our low. And this formula is going to be, in fact, let me go ahead and copy this as well over into the spreadsheet. If that is not helpful, I apologize. Maybe it's just helpful for me. We're just going to do this formula in the spreadsheet so we know where it's at. Where do we start out with this formula? Well, we're going to start with the forecast, which is 89.61 in our case. The book's .60. We're going to subtract the standard error times that probability, but we're also going to include, so we're going to multiply that by the square root of this factor. So we're going to do the square root of 1 plus our D2 factor here. And that's going to give us 1030.30. And again, there's a little bit of rounding error here off, but we nailed it. That's the high. And let's do the same thing for the low. We'll do our forecast plus standard error times the z-score. In addition, because we're now 2 weeks away, right, we're adding this factor of 0.168. So we're multiplying the squirt of 1 plus that D2 factor. And there we have the lower forecast interval of 748.92. Again, 1/100th error because of rounding. And we're good to go. Hopefully this helps. I will go ahead and post this. Let me know what questions you might have. Thanks.